Hello and welcome back to another live stream here on Mikey's Flightdeck. So, and finally with something I've never done before, we are making a live configuration today of a panel. And so this will be also the first time you will be able to see my new COM panel. So who's already there in the chat? Hello to Dennis Lander, nice to have you here. And we have Andres Santos with us. Good evening, hello. So, yeah, let's see how many people do we have here. Yep. Ferdi de Castro, hello. Yes, live stream, always beautiful. There are advantages and disadvantages in doing a live stream. Many things can go wrong, and I haven't tested the configuration before here of this COM panel, so it can be that nothing will work later. The advantage is that you don't have any editing work later. So when I'm filming a video, I can say I have around about 2 days, 3 days of editing, but this you don't have when you're making a live stream. Dan Barry, good evening, good to have you here. So let's see what we will do today. Let's switch here to the other camera. And here it is, the COM panel. You see there are already the 7-segment displays lighting up. This is just because I have added 5-volt power to it. So sometimes they are doing this. And I think it's especially when they are not connected to an Arduino. Here. Now it is connected to it, and we will see the it will change when MobiFlight is running later. Psychotech, I hope I have pronounced this right. Good to have you here. Hello. So this time I will connect the panel to the new Arduino number L, or with a letter L. And I think it might be helpful for some of you how I am planning the use of my Arduinos here. And I think this time, especially during the steps for the pedestal, I have done many things better than in my overhead planning. If you remember, I have said this at the last live stream. When I have done my overhead, I have searched for the easiest panel to build, and I started to build this and connected it with Arduino A. Then I took the next easiest panel to build and connected it with the Arduino A2. And when the Arduino was full, all the pins were used, then I switched over to Arduino B, for example. So this led to a very strange routing of all the cables behind these panels of the overhead. And yeah, all the cables are going from the left to the right because the Arduinos are in the order of their ladders. And so now when I would do it again, I think it might be much better than you look at the left, for example, of your overhead and clustering your panel segments. And all these segments come together to the Arduino A, for example. And yes, and then the next cluster of panels comes to the Arduino B, and so on. And so you have a bunch of cables running nearly the same direction. This will make things easier and much easier to find to get a special cable out there again. So what have I done this time? Here you can see a rough sketch, just a rough sketch. It doesn't need to be readable. It's just a sketch for me how I will connect my panel segments. You can see down here, these panels are already done. The videos are online. The that's not. Well, is that right? No, it's not right. They will come online. So with the Arduino J, for example, here the both panels here on the ADF panels are connected. And then here I have a whole bunch of panels come to the nav panels, weather transponder. These are all connected to the Arduino K. And the upcoming fire panel, fire cargo, and the COM1 panel, which we will configure today, will be connected to the Arduino L. So how can you cluster these panel segments? I have estimated the number of pins every panel will need. And so, yeah, I know a button will use 1 pin, an LED 2, also again 1 pin, and other switches will use 2, encoders will use 2 connections, and so on. And so you can estimate plus minus 2 connections how many pins every panel will need, and then we have the maximum pins available on our Arduino Mega, and so we can define clusters. Yes, so that's something maybe interesting for you, so that you can also plan your panels better. So who's else here? Stevie's DIY sim build. Hello, nice to have you here. Another DIY sim builder. So what have we here? I built a Cessna 172 home cockpit Hukar Clark design. Every step is amazing. Yeah. It just depends on the level of detail. I think when you are doing a Cessna really detailed, then you will also have problems and really challenging panels to build. Yeah. So, but now don't lose any more time. I will dive into the configuration, how I would do this when I would do it alone here for a video, for example. So the COM panel. Let's start I think, with the devices. This is how I always start the devices in MobiFlight. Oh. Here we are in my connection sheet. The connection sheet is available on my website. I update this every time when a new panel comes out. Then you will find the actual connection sheet online. And here, if you don't know this already, I write down all my Arduino numbers, all the pins where every cable is connected, the type of the device, the name which the device has in Prosim, which is useful when I have to search in the Prosim configuration for a special offset, for example. The color is only for LEDs, so I know which color an LED has and which resistor is used. And then we already come to the offsets, which type of offset is, and this has to be inserted in Prosim, for example. And it's also helpful in MobiFlight. There you also have to say which size and how many bytes you will need for this offset. And here is the bit of the byte which is used. When you don't use a full offset, then you can separate it into some bits here. And then here's some hardware parts. The D-sub connector. You can see this here. Every panel, there it is. It's connected with a D-sub connector. And in this case here, it is the L1 D-sub connector. And here, where it is, I think the L1 here. There it is, the L1 D-sub connector, and on which pin of the D-sub connector every panel sits. So this is important when you have to do some maintenance work, for example. Yeah, so now we do the COM1 panel today. So I think I can do a filter. Yeah, I will filter here on L, because this is right, not L0, I think. Yeah, because the COM1 panel is the only panel which is connected to the Arduino L at the moment. So let's start MobiFlight. So I will give it over to the screen here. There it is. So it is scanning for Arduinos, and yeah, found a board compatible. Yeah, and I want to upload the MobiFlight firmware. Perfect. This comes when you connect a new Arduino to your computer and start MobiFlight. Here you can see the update was successful. So when you connect a new Arduino to your computer and start MobiFlight, and then it says, hey, there is an Arduino connected. Do you want to make it to a MobiFlight board? So this is what I have done now. I will give it a name. Arduino. Is this a big L? There. L. Arduino L. And so I can also save the different configurations in a file. And so when my Arduino is burned or died for any reason, then I can take another Arduino, take the configuration file and update it with this, and it is renewed. So what do we need now? we will need two buttons, L1 and 2, and they are on A14 and A15, which are the analog pins of the Arduino. So I can say add a device and a button. L01, and it is pin A14. This is new here to MobiFlight. Before they also have given names to the analog pins, so they are a number 2 from I think 58 to 69, something like this, no? And you always had to look, A14, what is this as a number? And I think this is better now, and that they have these namings, A15, 14, and so on. So L02 sits on A15. There it is. So now we need the encoders. We have two encoders in the panel, the outer encoder and the inner encoder. L3 to 4 and 5 to 6. Okay. So we add an encoder. 2 pins are needed. So let's make the naming first. And I'm doing the naming like so, L03 minus 04. I'm doing this because I need one line in my configuration sheet for each pin here. And yes, you can give it another name, like COM1 inner enc, something like this, COM1 outer enc. I think these names become long, and I have read that MobiFlight might have problems with longer names, and so I try to keep the names as short as possible, but in a schematic way that they are logical for me, at least for me. And so I reuse the numbers, and I know the lines L03 up to 04 are for this device. I will do the same later when we make the segment display. So I don't know if you can see this here. You can see my segments are a little bit flickering right now, and I don't know if this is too good for this here. And so I will, can I do this? Deactivate the power for this for a moment. I'm just losing the D-sub connection. This will not interfere here now with the configuration, but yeah, I'm a little bit scared of this. So back here to the configuration. The pins, you can see this here, 53 and 51 for the left and the right pin. I always had problems to say which is the left and the right pin of an encoder, and sometimes this wasn't right, and so I have now these 2 pins inserted here. When we later see that we turn the encoder to the right and MobiFlight says, oh, it's turned to the left, then we just switch these pins here. That's all. The type, for me, the best type was this here, 1D10 per cycle 00. So, and now another encoder. L05 to 06, and the pins 49 and 47 49, 47. Here. Yeah, and now we are already here at the segment, the 7th segment. No, not the segment displays, but the max chips. There are 2 chips built in this panel, but they are, yeah, what's the name? Not cascaded, behind each other, and so you only need 3 wires to control them both. LED 7 segment, that's the thing we need here. And I have written, you can see this here at the right in my connection sheet, which pin is for which control. Yeah, Ben Derry, thanks. Daisy chained, that's the word, daisy chained. These chips are daisy chained, right? You can do technically 8 of them in a chain, but I think that isn't not I would not recommend this. So I have always used 2 of them here in a row. Let's see if you can use more when we come to the MCP. We will see. So L7 to L9, that will be the name here. L07 to 09. You see, so I now know and see there are 3 pins that are used by this device here. So DIN, which is this here, is the pin number, not the DSub pin number, it's 41 on the Arduino. CS is 45. And clock is 43. I hope that's right. And the number, there are 2 chips daisy chained. Oh, that's all. I'm also surprised. 2 buttons, displays, encoders. Oh, that's all. Now we can upload this to the Arduino. Finished. And we also saved this. Here you can see this is the folder where I have all my Arduino configurations A to K, and now Arduino L will come. So now MobiFlight says, hey, to do all the configurations that you have done, there are some Arduinos missing, but I don't want to take the Arduino L the place of some other Arduino, so it will be the only Arduino that is now active. There we are. So one word that I should have done before at the beginning. So just to tell you why I'm doing this live stream here, this configuration live stream here now. In every panel video now, I'm always saying when it comes to the configuration, when you want to know more about the details of configuring MobiFlight with Prosim and so on, then watch my video, you will see everything in detail there. Yeah, but where can you do this? I have linked the video, but maybe this is a really basic video with the basics. Of course, I also started with the basics and then dived into deeper configurations here. But now I think it can be helpful for many of you to see that there can be problems and difficulties, but how you can solve this and making again a full configuration just here for you. And not making a video with all the work I've said before, editing this, just making this live together with you. So if there is any one of you who has questions, just write them down in the chat. Now we have the time here to answer all these questions. So back to MobiFlight. Yeah, I said back to MobiFlight, but now really now it's always the time when I switch over to Prosim, which we should do now. All the devices are now there in MobiFlight, and now I will add the offsets to Prosim. Normally, I do this already when I write down here my new chapter for the connection sheet, and I look up the Prosim names. And when I am already in Prosim, then I can insert the corresponding offset. So let's start Prosim. And while it is doing this, these offsets here, I have said this in my firing up the overhead live stream. I had really huge problems with interfering offsets. Try to stay up in line with the offsets you are using and you have used. Document every offset that you have used here. And I have now started on my offset page here. Here I write down all the offsets that I can use. And here I write always down the last offset I have used or I have started to use. And when there are bits over, for example, take out here the filtering and have a look down in this list. Here, down here, you can see. Here you can see I have the offset 5321 started, and there are still 4 bits free to use. And so these always are at the bottom of my table. And so if I only have to configure a button, an LD or something like this, which only needs 1 bit of an offset, then I can grab one of these here. And this I have already done here for this COM panel. You can see this here, 531F. This is one offset where I use the number 4 bit. Solar Phoenix, hello, nice to have you here. Yes, you have already a few radios and trying to get them running in the transponder. Yeah, the transponder isn't designed yet. I will do this. A very a panel full of electronic and not much place for all the components. Ben Derry, what do we have here? With such a large project as your panels, are you ever concerned that you might run out of available offsets, or is it there enough? Honestly, I don't know. I think other people have done this too, so I hope I'm not running out of offsets. And this leads me right to a good example here. Because you see this here, the black offset. This, I hope that is true. I hope this black offset is the only free offset we are using today. All the other offsets come from different other places. So you always have to look out where you can save offsets. And there will be an example in the next upcoming video of the ADF panel where I can show you how you can save offsets. And here you can see these red offsets. Where do these offsets come from? What is it? That transfer? The transfer offset. Oh, I hope this will work. And the offsets for the radio frequencies, the active and the standby frequency. Let's have a look to the FSUIPC offset documentation. when we search for COM1, yeah, here you can see COM1 frequencies. And here on the left, you find offsets that are used by the simulator to transmit these frequencies. And these are readable and writable. This is not always the fact that it is writable too. Again, the upcoming video, this will be a good example. But here you can see the first part of the frequency. We will come to this later. For example, here 123.45 is represented by 2, 3, 4, 5. So the leading one is assumed, and where it goes, standby. Okay, I see. Other frequencies are splitted into two frequencies. What have I written down here? Here. 05cc, 05c4. Coming back. Here. This, okay. Okay, there are two ways for this COM frequency. Let's explain this here. So here you can find the COM frequency like this. 3 digits before and 2 digits behind the decimal point. I have read somewhere in the web, people said, oh, there are 3 digits behind the decimal point in the COM frequency. And so this was added to the FSUIPC, can I say SDK or something like this? Here you can see they are in another color. And there was added, you can see the difference here. This was a 2-byte offset. And now we have a 4-byte offset because the number is much bigger than the number that was transmitted before. And here now in these offsets, 05C4 and COM1 here and 05CC, there are the two frequencies for the active and standby COM1. So these are already there. I'm not using a free offset, and so every time when you have the possibility to use such an offset here from this FSUIPC documentation, then use it. You will save yourself offsets for other devices that don't have an offset here. Here, and this is what we will do. And these offsets don't have to be inserted in the Prosim configuration. Here, and now you know why the only offset we are now using is this one here for the radio test button. Here, let's insert this. There we have the Prosim configuration, and go to config and combine config tab, and again use the search function COM1. Now here we can see in the navigation category under switches, I think. What are we looking for? Radio test. Radio test COM1 pushed. This is the button we are looking for. And we use an FSUIPC 8-bit unsigned offset 531F4. So for the 4th bit here. Yes, okay. That's it. That should it be. The transfer button here for COM1, the same. 3, 1, 2, 3. Let's have a look here. I think we went over this when we searched for COM1. No, here. 3, 1, 2, 3. An offset to swap the displays here, and up here we find the COM1 swap. And so when we use the bit number 3, then it should send out the command to swap the COM1 displays. We will see if this works. So the configuration in Prosim is already done. It wasn't too difficult, I think. So now I open up Prosim displays, and we have to create a look to our COM1 panel. There it is. So nothing comes in our way. Where can I lay this? Up here on the left. Well, yeah, let's do this here. So 118. This is what the two frequencies are. And let's start with a swap button, I think. So go to MobiFlight, and we make a new configuration. Now the panel is in the way. L02. This is the configuration that I'm using, or I want to use for the transfer button. So then let's make this L02. Now be careful. There. When you activate the sorting, the ordering here of the description, then it will jump away. And you have seen this in the last video. This led to a misconfiguration because I haven't realized that I'm now clicking here to another line. So be careful. Yeah, L1, L02 we have here. And our configuration, an FSU IPC offset 0, 1, 2, 3. I hope this is right. 0, 1, 2, 3, and the third bit. Yep. Then size in bytes is 1, and the third bit. These are also new buttons. They weren't there all the time. Cool. Clear all, set all. Something that really shows that MobiFlight is always gets always better because it reacts to the demands of the users. What am I doing here? I'm talking to you, and so I'm making mistakes. What mistake have I done? I'm here in the Output tab. It happens from time to time. Switch over to the Input tab. We have a button here which makes an input, not an output. So 02, again, it jumps somewhere here. And again, input. This looks different. So L, my Arduino L is it. The device is L02. And now the input settings. FSU IPC offset, and again 5, 3, nee, not 5, 1, 2, 3. No, that's not right. 3, 1, 2, 3. 3, 1, 2, 3. 3, 1, 2, 3. Yeah, this is something where you can make mistakes, or where I am making mistakes and then wondering why something isn't working. So the on-press state, when I press my button, I will set the value to 1. And now again, a new function here in MobiFlight, copy. I can copy all this, what I have done here on this side, and paste it to the on release page. So, and the only thing I have to change is here the set value 0 when I'm on release. Switch on the logging. And now let's switch over to screen. We need the camera here, the camera, and you have to see the output here like this. Look here, when I'm switching the transfer button, yeah, nothing happens because I haven't connected them again. Oh, connection is there. And again, yes. So if you can't read this, it says found a configuration for L0 press and then L0 release. So the button is working. And now let's see. Let's see if this gives the information to the simulator. So we are again bringing up here our Prosim display and now changing the frequency here. Hello. I can't change my frequency behind the decimal point here. There. So, and when we now click this button, then they should change the positions, I hope. When we click, when we have to start prepared, I have it already here running, but I haven't started the flight. So I have started prepared. Let's wait for this. I have loaded the Prosim flight model. I don't know if this is this needed. So you can pause the simulation. There's no problem with this. So and now click run on MobiFlight. Nothing changes here at the panel, but when I now click, so he has taken different configurations. I have to change this again a little bit. Yeah, this isn't working. Yeah, I had this problem before. I think I have tested the COM2 panel before, and I found out that the offset from the FSUIPC documentation didn't work. Okay. So let's have a look at the COM2 configuration. Let's see if I have inserted another offset here. COM2 here. And the transfer, yep, here you can see I have inserted a free offset. So we can't save a free offset at this point. So, and now here come my free offsets in handy. I take the next free offset and paste it to the COM1 transfer button pushed here. There it is. So now we have to the Prosim configuration again. Go to Prosim, config, there it is, combine config, COM1, and go to the switch. The transfer COM1, here we have it. And we're given an FSUIPC 8-bit unsigned offset 5, 3, 2, 1, 4. This we'll have to insert in our configuration in MobiFlight. Again, I have already forgotten it. It's out of my mind. Too many numbers. 5, 3, 2, 1. 5, 3, 2, 1. And number 4. Next time you can write them down in the chat. We will work together. We make our way through this configuration today. 5, 3, 2, 1, number 4. Yeah. So I hope this will work now. Run and bring up the display. Yeah, you see everything here. And now clicking, and you can see they are switching the positions. And back again. Strike, first button working. So I'm now going out of this logging here, because it slows down MobiFlight a little bit. So next thing, we will make the configuration for the displays, so we can show up these numbers here. And we will make a configuration. So our display is L07 to L09. Can you remove the webcam? Yeah, of course, sure. Sure. So L07 to 09. And now going over to the output configuration. L07 to 09. And now we're adding again, for me, logical number 1. Why the 1? Because it's the first one. Here on the left, the first display. And for this, the configuration. We will do a second configuration for the standby display, and you can guess which name it will have. L07092. I think it is logical in a way, for me, maybe for you too. So let's make the configuration directly here up, and here you can see it. I've opened a different configuration. Here it is. So it has taken a value, but this isn't right here. It's the right value. So FSUR PC offset. Where is the first one hiding? 05C4. 05C4. 32 bits. 05C4. 05C4. David Nihia. Hello, nice to have you here in the stream. Sit back, grab a cup of coffee and enjoy the configuration. And if you have any questions, just write them down in the chat. So here we have 4 bytes. I don't think we have the binary coded decimal mode. The other offsets, these, you remember these shorter offsets in FSUR PC, they are in binary coded decimal format, but not this one, I think. So we can test the display already. So we choose the output device, module, Arduino L, a display module. Yes, this is the module L0709. And we want to configure the first one. We have 6 digits. We will use all of them. And the decimal point is on the 3rd one. I think when we test this now, this won't work. Yes. Here you can see it shows the 8s again. So what will help here? New start of MobiFlight will always help. So we have made the configuration. Okay. Now I close MobiFlight. I save my configuration. Always save your configurations. Nothing. There's nothing more worse than all your configuration is lost. So and starting MobiFlight again. Yep, I activate the camera again. Here you can see, and now the displays are off, and this is something different here. And now output. Where's my L configuration? Here. Going in to the display tab and test. Yeah. So here we have it. 1, 2, 3, 4, 5, 6, and the decimal point. You can see this here, the point. There it is, at the right place. So the panel is, from the electronic view, okay. Here, that's all we do right now for this moment. And now we will copy this configuration and give it the name 2 for the standby frequency. And the standby frequency comes from 05cc. 05cc. And again, 4 bytes, everything is the same. And the display is the second one we are using here. Everything else is the same. Test. Camera on. And now test. 1, 2, 3, 4, decimal point. Yeah, 4, 5, 6, everything is working. Stop. Okay. Cool. And now we don't. Well, yeah, we can just click run and have a look what happens. So run in MobiFlight. Ooh, looks good, huh? This is cool. I didn't thought that it already worked. 1, 2, 3, 8, and the 300, right? 132.35. What do you want more? It's working. Let's change the offset here. Wow, already working. And the numbers are like here in the standby. Yes, yes, yes. This is really cool. Okay, and then we should also use our transfer button, and the transfer works. Here, that's it. Okay, let's stop this. Let's come now to the encoders. The encoders here, L3 to 4 and 5 to 6. We start with the outer shaft 3 to 4. There is MobiFlight. The input tab. And I'm making a new configuration. L03 up to L, no, not L here, L to 04. Yeah, that's it. Activate it. And the input. So which module? My Arduino L. The device like the configuration 03 to 4. And now much more tabs here for an encoder. Though, what do we have here? Oh, we have seen something in the chat here. Just if there are some questions. I remember learning AV in high school. It brings me back and makes me feeling inspired. I'm surprised that they don't have a configuration has changed. Save configuration. They have it. They have it in MobiFlight. That's right. When you close this, then there comes a pop-up message. There are changes. Do you want to change your configuration? Yes, they have this. But when you click no, then it's away. So I'm really prefer the way just clicking save. So, and David Niai, what software are you using? As a simulator software, I think. No, it's the prepared software in the background. I have already tested this with Microsoft Flight Simulator. It works. It will work too. This combination here, MobiFlight and Prosim, will also work in the MSFS. So, and now back to the encoder setting. On left. On left. Now I'm thinking just a moment. Yeah, on left. We will do something on left. But later. I would tell you why. Because this, I thought in my mind, hey, where is the stream going? Why is it everything so easy? And then I'm nearly finished here with all the panels. But now comes the tricky part. We will save again some offsets. Because let me explain this. We could now enter another free offset here for these encoder rotations. Have I? I'm just turning it and thinking, is this already screwed tight here? Okay. We could use another offset for these encoder values and the change of the encoder for the transmitting to Prosim. But then we would, it would cost us some offsets. And there is another way of doing this, because we remember here in our configuration, we have found offsets for the standby frequency, which are already there, and we are already using these, and they are writable. And why should I use an offset for transmitting the rotation of the encoder when I could use my hardware encoder here and write the values directly? A little bit difficult to understand. It will be clear right now. So every turn of our encoder will not say to Prosim, hello, the encoder has turned. Do whatever you have to do when your encoder turns. But we will now here do local. Change the value and transmit the new value into the offset here and set it directly. And this will save us some full offsets. And an encoder uses 2 full offsets. So 16 bits. 16 bits. No? So we save 4 full offsets now with this method, with just adding a little bit of math. So, and we will do this like following. MobiFlight again. So we go into this configuration again. So we now have to edit the formula. I have it somewhere. here in my documentation. So on left, we will use an FSU IPC offset. And now we will use the offset we know already, 05cc, that's the offset, 05cc. It has 4 bytes. We're using all of this, and now we come to the set value. So now I will make the formula in another editor window. I think then we can make this bigger for you to watch here on your displays, monitors, whatever. We now have to think about how do we make this formula. Whatever here, a question. So as I understand, one method is to send the turn encoder left switch. The other method is to change the value of the radio frequency with writing a new value. Right, exactly. And I am using both methods here. You will see this in the next, in the upcoming video, the ADF panel. There, it wasn't working. The standby display wasn't writable. Come on, here we have the time now here in the live stream. Search for ADF, whatever, 1, 2, it doesn't matter. No, come on, where it is. Yep, here. What was this here? ADF frequency and send ADF frequency. Okay, cool. They have different ADF frequencies. Okay, so here, for example, ADF frequency. This is an example, the standby frequency. We can read this, but here you see this at the end. Not possible to write. We can't use this method here, what I explained now, with the ADF standby frequency. We can't write this offset, and so we can't set the offset. And there, the only way was to send the turning of the encoder to Prosim. And magical, Prosim can do this internally and set this somehow in the simulator. We can't, they can. And so every manufacturer of third-party software had this problem, PMDG, whoever, and they have found ways to simulate this internally in their softwares. And so do we, somehow. So back to the 05cc offset of our encoder. So when it turns left, we will do something with it. We just make now a 1 and on, copy it, on right, paste it. Yeah, right, +1, -1. So something like this. It doesn't matter. I just want to see if our turning of the encoder is right at the moment. So this was the outer one. Let's duplicate this row for the inner one. The inner encoder is 526. 0526. Okay, everything else stays the same. So when we now activate the logging and camera on, and can we already do this? Yeah. Here, I'm turning this outer encoder now to the right. Yeah, and it says right here, and it's not really grabby. I think I have to tighten the screws more, but left is left and right is right. That was what I wanted to check now here. And the upper one, here. When I turn this right, it says it turns to the left, and so the other way around. So this we have to correct for the inner encoder. The inner encoder is 5 to 6, and we will change this. We go to the MobiFlight modules and 5 to 6. So we just have to switch these pins here. So it should be 47, 49. So 47, 49. I have set different pins temporarily because when these two pins are selected, you can't use it here. So for example, here we have the 49, and here I can't assign the 49 anymore. This is good in most cases because you can't run into troubles like with the offsets when you use the same offset multiple times. But in this case, this is a problem. But when there are some pins left over, then you can find a workaround, or you have to change this manual via an editor in the configuration file. So this would be the hard coding way. So upload it, finished, save this configuration, and now test this again here. Now I'm turning this right and it says right, and we do left and it says left. So ready. George Lopez, hello, back to Mexico. Nice to have you here from all over the world. So, now to the formula. We will open a plain editor so you can follow me while I'm telling you what we will do. We have to take a look here first to the values that that such a COM frequency can have. So when we go down, what's the lowest value here behind the decimal point? 0, of course. So, and in front of the decimal point, I go down, 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 18. So, and I see 118 is the smallest value that our standby configuration can be. So spoken as one big number, 118,000. So, and the other way around, here, after behind the decimal point, there are always steps of 25. So it seems like, and this will be the biggest number, 136,975. And we have to, not make sure, we have to watch out, look, that the value that we are creating doesn't go out of this range. Because when you produce a value out of this range, you can write this into the offset, and it will it will come into this offset, but it won't have any effect on this display here. And then all internally it will calculate. It will continue calculating with this wrong value, but the display will not change. So if there comes a value that isn't in this range, it will be stored, but nothing will happen. And then you will turn your encoder and say, hey, I'm turning this encoder, why isn't anything happen? But internally there is something happening, but you aren't aware of this, and a mess, really a mess. It took me some time before I was aware of this fact. So don't make the same mistake. Look out which value you write into this offset. And so we will also make some observer configurations. I can show you this here, so you can control what value you are producing. So now here, let's say, how big is this? Let's make this bigger so you can follow here better. We will make a configuration. If. And there we are. I see in my documentation we have to do something first, because otherwise you wouldn't understand what we are doing here. We need these observers, yeah. What do we need? Let's have a look here. What do we need here? 9 in our value. Yes, okay, we make a configuration that we can use later here. And like the following. Where do we have this? How have I done this in the COM2? I have to watch what I have used in my COM2 frequency to show this to you. COM2. K31. Where is the encoder for COM2? K2728. There we have it. Okay, this is not in the input. No, not. We have done this here. Where have I done this? Sorry. Now this is what I said before. A live stream can also be difficult to make sometimes. Encoder. I'm now searching where I have added this formula here and what I have done. I think that I have done something here. Here. I'm reading out the COM2 standby frequency. Yeah, from this offset, and I'm making it smaller to calculate with it. Yeah. I show you in a moment why I have done this. Just have to look to this configuration here from the encoders. It must be here, I think, but we can't see this. Okay, we start. We make an observer for the COM2. What is an observer configuration? An observer configuration is something that reads out an offset, and this we will do now for the COM1 standby. I haven't found other namings here, so this I think is a naming that I can use here. All the configurations that I'm just using for checking some things. For example, if an offset gives a value to us here, I'm making here an OBS for observer behind this. So I know this configuration isn't used somewhere else for a real action, and I can delete it when I don't need it anymore. And these here don't have this OBS behind, so they are used in other configurations. So it would be really bad to delete them. This is what I'm doing with this OBS behind. So, and now COM1 standby. Where do we get this COM1? Again, from the offset 05cc. 05cc, 4 bytes. So just now, just deactivate this and run MobiFlight. So, and here, it's really small here, but I hope you can see this here. It's a really long number. On our display, this works because our display is only showing the first numbers here. And so all the zeros at the end are not shown. So everything looks right in our display. But if we would, when we now calculate with this number, then we would run into trouble because there are 3 zeros. Let's have a closer look. Yeah, I think. Let's have a look here to the standby frequency 136975. Yeah, the 5 is the last digit. Yeah. And there are 3 zeros behind this, really small. Okay. And now to make this number smaller, we are doing a transformation with this. And this is a transformation. The $sign, this is the value of that is in the offset. And we divide this value by 1000. And so we get rid of the zeros at the end. That's all. We could do this in our formula too. But this formula would get bigger and bigger then, because in every calculation step, and you will see there will come some configuration calculation steps right now, and then we would always have to do the dividing by 1000 first. It would become unreadable. And so I'm doing this small configuration here, which only function is reducing and get rid of these 3 zeros. Yeah, there are 3 zeros, yes. That's what I want from the chat. Yeah, so and now you can see the number is shorter. So stop it. And now we can use this COM1 standby. I hope, yeah, I hope. So we were at the input tab. I hope we can use this. What was the configuration we are doing for the outer encoder, no? Right? Outer encoder here, the 3 to 4. Yeah. Let's check. Okay, let's explain what I'm checking. So, I want to insert here the formula we are right now making at the other editor for you to watch better, but now we will use this value, which is without these 3 zeros, and we will reference it in the config reference tab. We will add a reference, and now we can take all other configurations that we have done, and yeah, and here we find it, our configuration that we have done at the moment, the COM1 standby frequency, and this we will use here now, and we can reference it with the hashtag sign. This is now possible here in MobiFlight. Before, a long time before, this was only possible to reference configuration in the same tab, input or output tab, but now you can, I think, reference all the configurations. So think about every time we will now use the hashtag, then we talk about the number divided by 1000. So back to our editor. If, and there it is, our hashtag, the value, this number where the 3 zeros are away now. If this number is bigger or equal, by the way, we are now, I will write this over here, we are now talking about the left turning of the encoder. So when we reduce our value, so when the value is bigger or equal 119,000, then we will lower the value by 1000. So why 1000? Let's write this down here. Let's say here we have 119. So here's our decimal point always, no? 119,000. So with a left turning of the outer encoder, we are lowering the number in front of the decimal point. So when we see this as a whole number, then we have to reduce this by 1000. And we can do this as long as our value is equal or bigger than 119,000. Because if it is 118, then we can't do this. We would come out with 117,000, and this, remember, would be out of the range of the allowed range of the standby value. Sure, and so we have to check this. So if it is possible, then reduce it by 1000. Otherwise, add 18,000 to it. So for example, if we have here the number 118,000, then we can't go lower with our value. Then we can still turn left, but what we have to come out with would be 136,000. We start again from the top. And this would be the same like we add 18,000 to our value. 118,000 plus 18,000, and we are here at 136,000. So, and now we can't write this value back into the offset because remember the number is 3 zeros longer. And now we have to add the 3 zeros again. So we will multiply this all here by 1000. And now we come out with a number that we can write into the offset without running into problems. So, and now we can take this formula and copy it and insert it here in our set value. There it is. This is on left. So, and on left, what have we on right? We need on right, left, right. I'm just looking down here. We don't need the on left fast. There we don't need any configurations. these aren't too many steps to route this encoder, so we don't add something where we subtract, for example, 5,000. This will work without a configuration for on left fast. So let's look onto the on right. Let's copy this here, paste it. So we have the offset, everything is right, but of course we have to make another formula. So let's switch back to the formula. Now, so everyone knows where we are. We are turning right. We are increasing the value. If our value is lower than 136,000, we don't. We have to look that we don't overshoot a value of 136,000. Then, like before, you can add still 1,000. Otherwise, the other way around, we will reduce it by 18,000. If you have followed this formula before, you know it's nearly the same here. And we multiply it later with 1,000 to come out with a number that we can write into the offset. So in this formula, we will insert here in the on right tab. So now we can change the numbers in front of the decimal point, down and up. Let's test this. So camera on, and we need displays. So the left, and you can see the 5 has changed. 5. Are these? This is turning through. I have to grab a tool. One moment. So there we are. I wouldn't have expected that I would need a tool now in this live stream. So just fixing this. Yeah, have loosened this. And now I'm tightening it again. The next live stream. Lasering and building a panel live. No, come on. Ah, there. Now it's tightening. Oh, come on, yeah. Oh, now we have it. Ooh, whoa, 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 whoa. Okay. Well, you see, we have to do something. Do some work. So, right, you can see it is going higher and higher. And a cool feature, no? It is already affecting the standby display, the value in the simulator, because we are writing directly into the offset. So let's see if it goes to a strange minus value shortly. And now go up, up, up. 36, and there we start from 18. I think these minus values come from the fact that we haven't done the calculation for the behind the decimal point values. I hope. We will do this now. So Andre Santos, a question. Why is it turn right not smaller equal 136,000 as it was for the left turn? Yeah, let me think one moment, and I can I can tell this. Yes, because I think then we should have said smaller equal 135. No, it has another reason. There was another reason. Yeah, and this will be the following. Imagine a value of this. This is the highest value this can have. If we would say, if let's say if the formula would be like this, if the value is smaller, no, not equal, then oh yes, you are right. Then it would not be true. Could work. Let's really, yeah, it's a good question. I don't know if I can answer this now. I thought there was a reason. I can't remember this reason right now. No, not now. Smaller. What is it? Maybe 15. Okay, I don't want to all you to have to wait for my thinkings. Maybe we could come to this question later again after the configuration of the values behind the decimal point. Then we can make some tests again. Okay. So let's go back to the formula for behind the decimal point, and this is really easy. Though behind the decimal point, we are talking about the inner encoder, which is this one here, 0506. And we will choose this here, 0506. The same offset. And we, again, adding our config reference here. Where it is com1 standby, and again it is used, the placeholder is the hashtag. So, and the formula. So a funny thing is that we don't have to look out if the value, I think if the value is come on here. Now we can't turn this anymore here because we get the value on another way. So on left short. We don't have to look if we are overshooting this value here because it is not getting higher and higher, but turning the inner encoder can also affect the value in front of the decimal point. I think I have tested this. And so my formula is really easy here. Maybe there is still an error in this, but then we will find this out today live. So left, we just reduce the value by 25 and later add 1000 to it. This is for left. And the right, maybe you can imagine, we will just increase this by 25. And this formula we will now insert here into MobiFlight. So on left, and this one here on right. That's all. So again, make a test here. I hope this will work. Everything will work here now. So the inner encoder. Always steps of 25. 750, 75. Now we should go to 8. Yeah. 25, 50, 74, 900. And now it will be interesting. It affects the number in front of the decimal point. I think I have checked this before in Prosim when I haven't connected this encoder here. Can we test this when I stop MobiFlight? Let's try this here. Yeah, now I can turn this value here. I tested this. When I turn this up, now let's see if they also affect the value in front of the decimal point. If not, then I have a problem, and we have to make a more advanced formula. 900, come on. No, it doesn't affect. Okay, then it isn't as easy as I thought. Okay, so we have to make a little bit more complicated formula. And when we go lower, yeah, we start again by 975. Okay, this can be a little bit more challenging, I think. So for all of you who don't have so much time, I will make one thing now, one last configuration that is missing here for the COM panel, and this is the test button. And then we will go back and make this formula here perfect. And yeah, just until it works. I think this can be good for all of those of you here watching this. So we have a half-finished configuration now of the standby value. So, and now here, this test button. Let's have a look what I think this does here. Yeah, where do we have this test button? We have assigned a free offset here. So L01. Okay. Camera away. So we make. Can you still see this? Yeah, here. So we make a new input configuration. L01. 01 I said. So there it is. And this will affect the Arduino L and L01 device, which is our button. And on press, we will trigger FSUIPC offset. You can see this up here. 531F. This is, we have already inserted in Prosim at the beginning. It's the 4-bit. And on press, we send a 1. We copy this and paste this on the on release tab. And there we will trigger a 0. So let's test this and see what it does. When we push test, you can see up here, the camera has to be where it is, there. So look what the display in Prosim is doing and what our displays here are doing. I push test. You see the difference. The displays in Prosim are showing zeros and ours don't. So what's the reason for this? I don't know the reason. I only can estimate the reason. And I think it is that this test function here is handled internally in Prosim, and the real test function in the real Boeing would also be handled locally in the panel, in the electronic of the panel itself, and set all those numbers to zeros. I think just to control if they can show any number, if they are not dead or something like this. But this in the simulator doesn't affect the offset of the standby and active frequency. Yeah, and so it is transmitted back here to our displays, because these are only looking at this offset, and as long as the offset has a number in it, it is shown, and there are no zeros, so no zeros are shown. Okay, so we have to simulate this internally here in MobiFlight with a configuration. Yes, and we make this like the following. I don't, yeah, what will we do? What have I done on the COM1? I still want to transfer, do I want to transfer this over to Prosim? I have to look, what have I done here at the COM2 panel. I don't want to show you something that is wrong. That's the reason. So K25, let's have a look in my K25 configuration. What am I doing there? Oh, shit, we can't. This is something sad. What is this? When the Arduino isn't connected here to the PC, then we can't see this here. We can see this still in the config file, but not here in the software. But we can change this. I have the Arduino K laying around here. What a surprise. And I can connect it. I have still a free USB connection here on my hub, and I can connect it. But then I have to restart MobiFlight. Okay, let's do this. This doesn't take long. And start it. So there it is back. So panel away, and have a look to the input configuration K25. Where is it? What have I done? Yeah. I'm doing nothing special here. I think I have done an output configuration. K25, I think. Yeah. Come on. Yeah. So what's this here? And I have called this an observer. I will explain this in a short for you. Okay, what I have said before, observers are only there so that I can delete this, and this is something I will do now here with this. Here, okay, I have made this test thing here. Okay. Yep. And what am I looking to? Okay. So I have made a configuration for the displays that will set this to 0, but I can't see the moment when this configuration is triggered. When would I do this? Now let's just think, how would I do this? Then I don't have to look up this. So when the button is pushed, then this configuration should be done. So let's make this configuration first. So what have I done? I'm making a new configuration for the displays. L0, let's look up everything for the COM1 panel. So my displays were these three here, L7 to L9. Let's look again to MobiFlight. There. So the active and standby. Let's duplicate this. And we call this test. So what should this configuration do? Yeah, sim variable, FSU, RPC offset. And I think I have... What have I done there? Oh. Okay, I take just a zero offset, so the offset doesn't matter really, and I will just make a transformation to 0 with the value. So again, for you, where is my L configuration? Here. So I'm now inserting zeros for the offset. It doesn't matter what this offset is. I just say the value what we want to show here now is 0. That's all. It is 0. Let's try this so we can see how this comes out. 709 on the first display, which is the active one. And now here we are don't using the decimal point. And now switch on the camera so you can see this, test it. Test it. When we test it, it will show numbers. We make a run. So and now, here you can see. It is flickering now. We will get rid of this problem. I think I can redesign this here. It is flickering because there is now a conflict between two configurations. Our test configuration, which says show zeros, and there is the other configuration, the normal active configuration, which says please here show the correct active frequency, and they are switching positions all the time. But you can see the zeros are working. So and now we have to get rid of this conflict and tell this configuration you should only be active when a special condition is given, and the other configuration too. This should also only be active in a special situation. And what is this situation? When this button is pressed. And now we have to look out of the state of this button here. Yes. And we will do this. How have I done this here? I would do an observer or something like this. What have I done here? Unreleased, no, there it isn't at the K25. How have I done this? I really can't remember how I've done this. This is a shame. I'm thinking about variables. Okay, let's have a look at the chat at the moment. Some more questions here. Why is a turn right? Also, now that we had, what happens with the current configuration when you dial the outer dial from 35 to 36 and from 36 to 18? Yeah, the outer configuration will what happens with the outer configuration when you dial outer dial from 35 to 36? There nothing happens. It just switches to 36, and from 36, yeah, it just reduces the value by 18,000. Then you are down again on the start value. Can you just mask the value as 0 if the test button is not pressed, but 0 if it is pressed? Mask out the value. Yeah. The problem is there aren't enough possibilities inside a configuration to mask out value. Normally we would be here. This is the active frequency. This is what is responsible that something is shown in the display. And here we don't have any possibilities to mask it out in a special condition. No, this is something we don't have, and I think we have to look here at the preconditions. I think no, I haven't. No, I haven't done a precondition. What have I done? Have I done a local variable? Can't remember. I can't remember what I have done. I think the easiest way would be a precondition, maybe. So let's. If we would solve this completely internal, let's try this. Our L1, L1 is the test button. Yep. Our L1. When we would say this button doesn't store its value into an offset, but into a configuration. As preconditions, we can only use configurations. I think let's test this before. Let's check this here. When I'm using a precondition, and I can't also, because this is a non-active one here. Precondition and type. I can only use a config item. Okay. MobiFlight also has internal variables, very cool, but not usable at this point here. This would also be cool if we can grab a local variable here. So we have to look out for the state of a button in a configuration. I think this is possible. Yeah, and here we are at the output tab, and we are making a new configuration, and I will call this also L01 because it is looking to this test button, which is called L01. So the FSUIPC offset, we use the same here. 531F and the 4-bit 531F and bit number 4. Here, and now it is just looking to it. Let's make a test. And yeah, you can see the value changing every time I'm pressing the button. It is the value of 16, okay, because it's a 4-bit. If it would be the 3rd bit, then it would be, I think, 8, no? Yeah. We will make it a little bit easier for us. So if we use another offset in the future for this, then the value wouldn't be 16, no? It would be another value. And I would just like to use a 1 or a 0. 1 if the button is pressed, 0 if it isn't pressed. So we make a transformation. Or we can we make a comparison? Yeah, we can do a comparison, I think. If the current value is 0, yeah, then set it to 0, otherwise set it to 1. I think this will work already. Let's test this. So it is 0. Yeah, and you can see here in this tab, it is 16, but it is changed to 1. And 0 again. Yeah, this will work. And now here in the L01, and I'm changing the name, changing the name to var. Why am I doing this? Because it is not a normal configuration, like, for example, an output configuration for an LED. But as var, I say it is a variable for me. I'm using it in another configuration. So, and now I will say this test configuration is only active when the test button is pressed. So I'm going to the precondition tab and I'm saying use a config item. Which config item? Which we have done right now here. L01 var if the current value is 1. So L01 var is 1. Then this only then this configuration will be active. And the other way around for the other configuration. We only want to show the normal active frequency when our config item L1 var is 0, so the button isn't pressed. And I think now these two shouldn't come into trouble anymore. Yeah. Oh yeah, this is working. Here. You can see there's no flickering anymore here at the display. And you see this red exclamation mark, this white and a red dot exclamation mark. This says this test configuration isn't active at the moment. And when I now press it, it should switch. Here. Now the other isn't active at the moment, but this one, our test, is active. And now we are flickering free. We have flickering free zeros and the other way around. Yes. So, yeah, it has taken a little bit longer, but at the end, this was exactly what this live stream was made for. Running into some troubles and finding solutions. And this is what configuring your panel is all about. Thinking how you can make the things work with a setting you are finding. Thanks, Dan. Thanks. Okay. We're making now the other configuration. So we copy, do we copy this or we will copy this here, I think. Yeah. So now duplicate the row for the here standby frequency. Test. And here we again want to show 0. So the offset doesn't matter. And we transform it to 0. And the precondition will be the same. We will select our config item L01 var if it is pressed. So if it is 1, then our test configuration will be active. And the other way around with the normal display of the standby frequency. If our L01 var is 0, so the button isn't pressed, then the normal standby frequency will be shown. Oops. So there is the test. We press the button. Yeah, because we still have the offset transmitted to Prosim, so Prosim displays is showing these zeros, and we are doing it here too. So in this case, I don't know if Prosim has these. There are a lot of failures that can be simulated. Maybe they have a failure like here, the digits are dead, the hardware digits, and to simulate it, they will make this off maybe, and then I think the test should also show something, but this wouldn't work here on our panel. Forget what I said. Yeah. No. With this configuration, we can find hardware failures in our panel here. Yeah. I think we should dive more into this. It works. That's all. Enough. Yeah. So, yeah. We have now configured everything here on this panel, and now we go back to what I said before. We are looking at the configuration of setting this value here right as Prosim does it. So back to thinking here. What we have found out is that we go higher here, then we start again behind the decimal point, counting from 0, and so the other way around. So let's do this like before, so that you can see what I'm writing here now. Our value range is from 0 to 975, if I'm right. Yeah. So this is the range where we have to ensure that our value is always in this range. So back to the inner encoder configuration. Inner encoder 05 to 6. That's the configuration. On the input tab, 05 to 6 here. There we are. Let's get rid here of this logging. Oh. Yeah, the display here, the panel away. So to the formula. I will copy the formula to the editor so you can see what I'm doing. So as we have said, this formula isn't enough. Just lowering the value by 25. We have to do some checking like before, that we don't go underneath 0. Yeah, or more. We don't go beneath lower than 0. We are just reducing our whole number more and more by 25. And this is why we affect also the numbers in front of the decimal point. So that we have to make sure. So how can we just look at the end of this value? Yeah, I have to think about this a moment. Maybe we can have a look at the configuration that we have done on the nav panel. Maybe there are some ideas. Nav panel, where are you? ADF, come nav here. There's a nav and the encoders for the nav panel, the inner one, K20 and 21. Let's have a look. K20 and 21. There it is, the inner encoder. Let's have a look to this formula and think if it is saying something to us. Yeah. So that it will be clear for you. Let's have an example that we have a value like this. This is the frequency we are having here. And now we only want to affect the numbers behind the decimal point. And I'm doing a modulo operation here. And this is the modulo operation because I think the nav panel only had one or two, I think two numbers behind the decimal point. So this should be another modulo operation. Let's develop the formula up here. We will make a modulo. I think a modulo is the right thing we have to do. So if you don't know what the modulo operator is doing, a modulo operator is dividing a number through this number here. So this number is divided by 1000, and the rest of this dividing operation is the result of this here. So if we would divide this number, if you think away, don't think at the decimal point. If you divide this number by 1000, then 125 times it can go in completely, but there will be a rest left over of 625. And so when we do a modulo operation with this number of 1000, then we have this number here. So if our value modulo by 1000 is 0. So when can the rest be 0? In our case, when we have a setting like this. So if we divide this by 1000, then there is no rest because 1000 fits in 125 times perfectly and the rest is 0. So then we can't turn more to the left, but we have to start again from our maximum value, 975. So then we will add 975 to our value. So we are back there at the top. Otherwise, we can still, this is what we are doing here. So then we can still subtract 25 from our value. So and at the end, we will again multiply this all by 1000 to again create this big number we had before. I think this can work as a left formula. Let's have a look. And insert it here on left. And now we will have a look to the at the on right. Again, we look to the nav panel here. There's is no it's always fair. Look at other configurations you have done. You don't have to invent the wheel new every time. How you would say. So let's go. This formula is a little bit bigger. A little bit, just a little bit. So if we can adapt this to our need. If again here the modulo 1000 is 0, so again, so now we are talking about right, no? So we are at in our example at this is the maximum point where we have to watch out. If this is 0, so in our case we are here exactly at the 0 point. Then we can still add 25 to it up. So otherwise, and we're starting a new if course here, if our value plus 25. So this is this case here. So if we would add 25 to our value and make a modulo operation with 1000 and then the result is 0, then we know we are at the moment at this setting here. And then we can't just add 25, but we have to fall back to 0. Then we have to subtract 975, so we are back to 0. Otherwise, if it is 0, so the setting is, for example, this here, then we still can add 25. So I think this formula will work. Oof, I have to show this in the video again to you. Wow. I see hard editing work coming. So this live stream isn't the only video where I explain this panel here, but I will also make a video, and there you have all the configuration in short. No? But here you have the advantage that you see the whole development of this. So I think this can work. Let's make a test. Running MobiFlight, display and camera. So, and what here we are already at this setting, at the special setting, but we will turn left. So left, and you can see we are lowering it, and now turning right. That turning right, shit, it isn't working. Okay, only the left is working. Why is only the left working? There we are. The problems are coming. Why is only the left working? Is the right... so the first thing what I have to check is MobiFlight seeing that I'm turning right. Yes, it is. Oh, I can't see this. Here, every time I'm turning right, it sees you are turning right. So the hardware is working. So the problem has to be here in... I know what we have done. The problem is in our formula. Oh, yes. Do you see what I have forgotten? That's the question to the chat. We have talked and the hint I can give you is big number. Do you know what I have forgotten here in the formula? I will tell it. It's so simple. I think this is a problem. I hope it is the solution. Otherwise, yeah, I don't know. So run and right turn. 9. No, it isn't the solution. Okay. I thought it could be the problem because that would be run into something when we only change something in the number that doesn't fit into this offset. Then it would react like this. You're seeing nothing changing, no? What I said before. Okay, so still we can turn to the left, not to the right. Okay. We will now observe the value. We're already observing it. You know the configuration we are using here. Here, our COM1 standby frequency. Yeah, okay. So also the COM1 standby C isn't changed when I turn it to the right. Okay. Then I think we aren't setting the offset correctly. But why don't we do this? It worked before or not? Ah, Revo truck driver. Nice to have you here again. The man who never missed one of my live streams. Thank you for having you here. I need you more than ever. Oh, I hope you have a mathematical background. So 0.5cc. Yeah, but it's the same offset like on the turn left, so it must be right. Difficult. Our reference is right, so we are referencing the same number. Why isn't it changing the value when we turn it right? Oh, a short reaction, but okay, let's now we have turned left so much we can at least test the jumping over the zeros here. So now we go lower, and now we go to 0. And now we shouldn't go to 121. Yes. So this the left works. It jumps back here to 975. And then we can continue turning left, but the right isn't working. Why isn't the right working? If our value. Oh, chat. You could have helped me here. This is the problem. We are using a reference sign that isn't declared before. Who of you has seen this too and didn't inform me? Do you find this funny? Oh, yeah. Yes, it works. We have it. These are the moments normally when you sit late in the night and your configurations aren't working, and then you just go back for a while, for a meal, for sleep, and then come back after a while, and you will see those errors. Yes, then. Yeah, sounds like MobiFlight should write an error check for unused variables in a future release. Yes, Sebastian, if you are watching this live stream to the end, please, you can throw an error message that I'm using an, how it is declared, an undeclared placeholder. This would have been helpful in this moment. And MobiFlight has these options. It gives you, sometimes when your formula isn't right, there is an error in the formula, it can throw those messages. Yeah. So, so now let's test this. If we are going up, it should fall back down to 0 without changing, yes, the values in front of the decimal point. And now let's switch. It works. Ladies and gentlemen. Oh, I have to make the announcement like this. Ladies and gentlemen. You have seen the birth of the configuration, the full configuration of the Communication 1 panel now. With everything that can jump in your way when you are doing this. What have we had? Wrong pin assignment for the encoder. We have run into an offset that should be usable but isn't in this case here. You remember the transfer button. Wrong formulas. Yeah. And everything worked out fine at the end. And how many of you were still here? Oh, I think not too many have jumped out during this time. So congratulations, you have just made your way through nearly 2.5 hours of hard configuration work. And I hope I could show you some points or techniques you didn't know until now. Maybe it was helpful for you, or will be helpful for any one of you who will watch this live stream here later then. here. So I think that this was a really successful evening for us all. Are there any more questions? Yes, Andre, still there. Me too. Are there still any questions of you now that I have opened here my whole configuration setup? Anything that I should show you, or you have a question that you long time wanted to ask? Then you can do this now. Think a while I'm again and now making an announcement for the FS weekend. So I think you have watched, seen, read my newest event annunciation on Facebook. If you are following me on Facebook, the FS weekend will take place from the 5th and up to the 6th of November this year in Lelystad in the Netherlands. And it is a big fair, or even world biggest fair of simulators, and many home cockpit builders will be there, and professional manufacturers as well will be there, yeah, this time, for the first time, I will be there too, not as a visitor but as an exhibitor. And so I will take my overhead with me and my pedestal if it is finished until then. And yeah, I will be there the 2 days, and you can come and meet me, and we can talk about our projects and what we have done so far. Yeah. And this, I think, is a great chance to come in touch with each other. Andre Sanders, I'll be there already looking for a hotel. Yes, have a look. There is really a new hotel is built there. I'm there too. Just have a look here at this year, the FS weekend. So the exhibitors list here, what have we here? The Dutch Flight Network, ACC Flight Simulation. So the Civil Flight Sim Clubs, we have military squadrons here. Here we have the home cockpit builders. Mikey's Flightdeck is here too. And yeah, we have virtual airlines there, and professional builders like Prosim, Aerosoft, the Flight Sim webshop is there. iVeo and VetSim are there, and many others. So this site is still under construction here, and some more exhibitors will follow. Yes, and when you are searching for a hotel, let's have a look here. Oops, and Google. Let's have a look. Where is this aviodrome? Yeah, there we have the aviodrome right to the airport, and just the road up here, there, I think where it is here, there is a new hotel. So here is the museum, and up here is the hotel. funny thing, it is on Google Maps, it's still under construction, but when you are going there via Google Street Views, it is a little bit more finished already. So I'm really excited. There I will be the 2 days, or the nights only, I think. Yeah, so enough rooms for all of you. So there is one possibility. Go in there. And yeah, and then we also can have breakfast together. Whoa, great chance for all of us. Yeah, so I think no more questions here from the chat now. I can say then only thank you to you all that you have been here. I've had fun, and I'm really happy that I now have configured my new communication panel here, and it is now finished to go into the pedestal. Okay, I have to change the 7-segment displays to red ones now, but this is another topic. Okay, then have a nice evening, day, whatever it is at your place, and I think we will see us in the next video, and I will see us all soon back on the flight deck.